in the methods chapter. We've covered actually more than half of it. The chapter does break kind of evenly into two parts. One is the method syntax in detail, is what the different types are, how to write them, and how to use them. And we stopped here on what I have as slide 21, which is access modifiers. So access modifiers is a topic we have talked about some, and you have used access modifiers, but for the most part, I've avoided talking about it. Also, it isn't crucial that we set any of these today, certainly in terms of chapter 9. These will become important, though, in the next chapter, chapter 10, when we start making our own classes. So I introduced this here in chapter 9 and talk about it some and give you some examples to think about, but it is in some ways largely a preview for this topic in the next chapter. So first off, what is an access modifier? It's simply a keyword that we can add to a variable or an object or a method or even a class that will additionally influence its scope. That is, whether objects created from other classes can access that resource, that variable, that method, that class, that object, whatever the case may be, that you've provided in your class. You know, it's kind of common in most complex Java apps that you're going to have lots of classes. You know, and even in this exam, you had an app class and you created your own custom JPanel. So you actually did have two classes, and it would have been okay to put that custom JPanel in its own class file, in its own .java source code file. That would have worked. It would have made it less privileged. The way we wrote it, or the way I encouraged you to write it, was to write the custom JPanel inside of that app2 class so that it was what we call an inner class. Once you move something out of the class, it's a normal, regular external class. And so to a large extent, that's what we're introducing today is what if it was not an inner class? What if it was a regular class? And yet we still wanted to get access to things like the price or a color. Those are attributes of our class. And we'd have to think through whether we wanted to make those visible externally or not. So public entities are widely usable. They're visible outside of your class. If you made stuff public, for instance, in your custom JPanel and then tried to access it in your app, you would need to make it public or default, which we'll get to later. Private is the exact opposite. So private is saying this resource, this variable, this attribute, this method, this object, whatever the case may be, is only for use internally. I use it inside of my code, inside of my app, and I don't want objects created from other classes to be able to see it or use it or change it or set it or anything. So private is the most restrictive access modifier. Public is the widest open, the least restrictive access modifier. To back up just a tiny bit, I would also say, even though we haven't been using these, we also have been using them because all of the apps that we've written, you've typed the word public a number of times. Every app that we've written has been a public class. If the app is not a public class, Java can't run it because it would be restricted from accessing it. The main method is also public, and there are other things that have been public. You've typed the word public. Certainly, by this point in the semester, you've probably typed the word public 100 times or more. And all that means is you're granting that class or that method or whatever you put public in front of wide access to make it easy to use. So moving back to a more concrete little example here, I've tried to do this really visually, tried to use colors as well. So I've got two classes, and I've called them Class A and Class B. Class A, you can see there, is highlighted in purple, and it has one attribute, which is a public integer called value, and the value set to the integer 10. And then I've got Class B, which is highlighted in orange, and it's also got an integer attribute, also called val, but it's set to 20. The key difference, obviously, that I kind of didn't note is that the val in Class A is public and the val in Class B is private. So I have two classes. I don't give any details. These could be two JPanels. They could be, subclasses of JPanel. They could be something else that we've written, although we haven't gotten any. We won't get to anything else until chapter 10. So for all intents and purposes at this point, if you wanted to make it more concrete, Class A and Class B could be custom JPanels, and just like the ones you're working on or did work on the exam. And there's one attribute in each, so they're tiny, very simple classes. And then I've got an app that's going to use them, and it's highlighted in green. So I called the class my app, and I create two objects based on classes A and B. And so notice also that classes are capitalized, which is the convention in Java, and objects and variables are start with a lowercase letter, which is the convention of Java. So I've got this kind of pseudocode up at the top. I'm creating two objects, lowercase a and lowercase b, based on the classes uppercase A and uppercase B. And I've tried to stick with, I hate that color. I gotta fix that color. Maybe that contrasts the best. Okay, so two classes, A and B, and this app, I create an object lowercase a and an object lowercase b using this new instantiation syntax. And again, this is not great. This is not really Java code. I'm mixing symbols and colors and stuff together. And then I've got two icons, a visible icon and a not visible icon, which we've used before. Inside of my class, what you see is I've created these two objects, lowercase a and lowercase b, and obviously they're both visible because I've created them as instance variables, so I can use a and b right away in my app. There's not much to do with a and b since they only have the one attribute. So in my constructor, I'm just going to try to use the attribute. So this is my constructor, and here on the first line, I'm setting a variable I call val_a, and I'm setting it equal to lowercase a.val. So I'm trying to reach into an object based on this class which has this attribute, and it is public, so that'll work. This first example line with the green eye next to it says, yeah, val's visible, that line of code will work, and val_a coming out of that would have the integer value 10. It's just reaching into this object which has this attribute declared and defined, and it's defined as public, so that works. If I try to do the same thing, however, with object B is trying to reach into the object and find this attribute, but it can't see it. So it's not even the case where it can see it but can't access it. As far as Java is concerned, this private attribute outside of this class just doesn't exist. So if I try to access it here, it's not going to work. Val for object lowercase b is out of scope because it's been privatized and is essentially hidden from us. For some of the stuff, the definitions make sense to people, and then for other stuff, something more visual makes sense. And then we'll also do some of this in Eclipse, actually typing code, which is, the third big way I think people get their heads around it. All right, that which must be done in public. So here's the short list of stuff that needs to be done in public. Any top-level class, including your app class, that contains, say, the main method, absolutely has to be public. If you made your app private, again, the runtime environment would not be able to create an app from that class definition because it wouldn't have access to the class definition. Likewise, the main method itself, which has to run when an app starts, has to be public. If it was private, once again, Java would not be able to start your app. The event handlers all have to be public. I think most of us have gotten into the habit of letting Eclipse, or more generally our IDE, write them for us, so they've all been made public. But I think that probably makes sense because, again, the virtual machine needs to reach into your app to run the event handler when the user clicks a button in your app. And so if the event handler was private, the virtual machine would not be able to run the event handler. It wouldn't work. And then get and set methods, generally their entire purpose is to be public, is to reveal things that you can get from the class or from objects created from the class. And the set methods are things that you have access to set inside of objects created from the class. The idea of a private getter or setter would be kind of an odd idea. The only restriction is that only one class per Java source code file can be public. So that's a bit of a weird restriction. But if you have an app that contains lots of class files, which I know I do a lot, you just remember that it's the public class is the one that contains the main method that launches the app. After that, you just leave off the keyword public, which makes them default their package access, and in general, that'll work fine. All right, method overloading. We did talk about this a little bit when we were looking at the code for the Pirate customer report. We have in that, if you looked at the code, or if you were here Tuesday or watched the video from Tuesday, you know it has multiple methods with the same name called drawLine. There's a drawLine that just draws a default line, and then there's a drawLine that takes a style parameter to let you specify whether you're drawing a line of hyphens or a line of equal signs or a line of tildes, I think are the three styles. This technique is called method overloading. So you may define multiple methods in your app that have the same name as long as you give them distinct parameter lists. So the data types in the parameter lists have to be distinct or distinguishable. As long as you do that, Java has no problem keeping track of these multiple overloaded methods because it will run the one that matches the data that you pass to it. So in the example, you can tell if I call the method drawLine and don't pass it an integer parameter, then it runs the default drawLine method that doesn't take a parameter, which draws the default line, which is the hyphen line. If I call drawLine and pass it an integer, then it's going to run the version that accepts an integer, and it'll use that number to identify a style. Inside of that drawLine method, there's an if, else if kind of statement. And based on the number you pass to it, it draws a line of a style, of a requested style. So Java's not confused. As long as you can keep overloaded methods straight and you know which one you're calling, certainly Java doesn't have any difficulty keeping track of them and calling and running the correct one. Here's the two methods just to look at. We looked at these Tuesday in the code as well, but this is also here just for reference. So the default drawLine, you'll see, takes no parameters. It's a void method, which means it just does something. It doesn't return a result. And then you can see the lower method is the style parameter version of drawLine, and it takes an integer. And then if the integer is 1, 2, or 3, it draws one of these lines. And you might note if you send it a style number that's not valid, it just doesn't do anything. So that's just a design choice. You could also have a catch-all, like if you don't pass it a valid number, maybe you have it draw, I don't know, a row of X's or whatever makes sense to you as you're coding it. But as is, if you tried to run drawLine and passed it say a 0, then it wouldn't draw a line because 0 is not one of the styles that's detected. We talked about nesting methods Tuesday, so I did jump ahead quite a bit, but it made sense because we were working in a method in Eclipse, and it made sense at that point to try to add another method inside of it. But the big picture idea simply is that Java does not allow you to nest methods. And by nest, I mean to place a method declaration inside of another method declaration. Other languages, not all other languages, certainly, but there are other languages that do allow you to do this. In the mobile app course, we use Lua, and it does allow this. And I actually make use of it sometimes in class where it makes sense to have something that you would consider a local function. But Java doesn't do that. So if that's a skill or a capability you want to have, then Java's not the language for you. Although after we cover Chapter 10, there are ways to get that functionality, and vastly more, by creating your own classes. But if you find yourself tempted to create a method and you're inside of another method, you just have to make sure that you put that method in the proper location. So methods have to be inside of classes, so inside of the curly braces that define the start and the end of the class, and then outside of any methods. All right, like I said Tuesday, I think one of the most common ways people start writing methods is that they write some code that's good and that works, and then they realize, I need to do that again. I need to do that same thing again. And it's not a situation like repetition where you're going to do it multiple times sequentially right away. It could just be later when you're coding, you're in another method, maybe you're in another class or related class, and you decide, I need to do that same thing again. And then you're tempted to, copy and paste. And we talked about this a little bit last time. And I mentioned this in both of my programming classes, but in general, if you find yourself wanting to copy and paste, maybe you even have it already on the clipboard. I would love it if you pause right then and think, is this really what I want to do? Copying and pasting in programming generally should set off a little bit of a red flag because There will often be a better way to do it, and in the long run, an easier way to do it. It is almost always the case that if you find yourself copying and pasting something, that you'll need to do it again. If code is so useful that you're already reusing it, you will probably find that you need to use it again, maybe several times. So the copying and pasting then becomes more of a chore, and like we talked about last time, it introduces redundant code into your app, and anytime you have redundant code, there's the possibility that redundant code will in some ways get out of sync. You'll make fixes or changes to some of them, but not all of them, and then you'll have inconsistencies that are hard to track down. The advantage of the method is, once you put it in a method, all you do is call the method. If you want to change or update the code or revise the code, you can just go to the method and change it. In other words, sometimes you'll start your app with the explicit goal of having several methods and you'll know them in advance. But the other common way is that you've written this code and then you realize, I would really like to turn it into a method. So this is a cool feature of both IDEs. In general, this falls into a category of coding called refactoring, which is just a term that means making changes to your code to make it clearer and easier to work on and work with without changing any features. It does allow you to make specific changes that are helpful, one of which is you can identify code in your app that you were just about to cut and paste, and instead refactor it and let the IDE turn it into a method for you. So that's a pretty cool feature. So I'll tell you about it, and then we'll actually, we'll play around with it and do it. In Eclipse, what you'll do is highlight the code that you want to use. And again, you might have already highlighted it. You might have already copied it to the clipboard, and then you think, wait a minute, he said red flag, red flag. What do I want to do? And then maybe think about doing this instead. Instead of pasting it somewhere, right-click and say Refactor and Extract Method. That'll give you this dialog box that you fill out, where you can give your method a name, and you can think about, well, the access modifier, you can think about, does it take any parameters? The cool thing, though, is both IDEs will try to analyze the code that you've selected and figure out if it would need anything passed to it. And if it does, they'll show up here as by default, right here. So it's pretty cool. And it also previews what the signature will look like based on the selections you've made, so that's one more check. You can look at that and think, does that look right? I think that looks right. Okay. And then, you hit the OK button. So the cool thing also is in both IDEs, they'll write the method, they'll move your code that you selected into the method, and then they'll replace the area where it removed the code with a call to the method. So the result of this refactoring, again, follows that basic rule, which is it's made a structural change, but it hasn't changed what the program does. By calling the method that you just created, it does the same thing as if you had left the code right there, but it's now created this method that you can use in the future to do stuff. The chapter then looks at Unified Modeling Languages, or language, or UML. Let's jump to Eclipse and maybe do some stuff with methods and refactoring, access modifiers and methods and refactoring. So I'm going to share my screen. So let's just start a new chapter 9 example. Let's just do this more from scratch in there. So I'm going to create a new class called AccessDemo. So it doesn't need to extend JFrame, but it does need to have the main method, which I forgot to check because I was talking while I was doing the dialog box. So I need public static void main string args. And then I need to create the app, so I'll say AccessDemo app equals new AccessDemo, and then I need the constructor, and we'll do most of the stuff in the constructor. All right, so if you're trying to follow along, that's the basic skeleton outline of all of the apps, all the simple apps that we've written. So there's nothing event-oriented here, so there are no events or listeners added, and it's not a GUI app, so that doesn't extend from JFrame. There's no need to size and set up and configure the window, so it does make the app quite a bit shorter. So what I want to do is say, add these two classes, A and B. These are much like, obviously, the example in the Keynote. So let's just follow along with that. In class A, I'm going to say there's a public int variable called value, and it's set to 10. And in class B, there's a private int variable called val, which is set to 20. So this looks a lot like the example in the Keynote. So let's try to do some stuff. First off, I need to create objects from those classes. So I'll say A, let's name it maybe object A, equals new A, and B, object B equals new B. So all that's doing is creating two objects, one called object A based on class A and one called object B based on class B. Again, these classes don't have a lot going on in them, but they do have variables. So let's try to access the value that's in object A. So it's object A value equals, and the syntax would be object A dot val. And you can see, you might be able to see, it shows up in the IDE's autocomplete options. Because it's public and Eclipse has already scanned through the class and already knows what you've defined in it, and it's ready to use it. So object A.val works great. If we run this, it's going to say object A val equals 10, which is correct. It is 10, and the line of code and the syntax works because it's public. Let's try the same thing with B though. I mean, you already know what's going to happen, right? But object B val equals plus object B dot, and I'll pause here just to look at the autocomplete options. And you'll notice conspicuously missing is val, right? Where in object A, it was the first option to select. It's just not there in B. And you might be tempted certainly to just power through and type it yourself, which is fine. You can type anything you want, but you'll see right away that val is underlined. Let's hover over and see what the error is. The field b.val is not visible. So public instance variables are also referred to as fields. So that's not going to work. If I try to run it, I don't think it'll run. It's just going to, yeah. It's going to try to run and say, no, unresolved compilation problem. All right, so the issue is, right here, is we've made val private. What that means is we can do stuff in class B. For instance, if I have a constructor, I could say, val equals 15. I can change it. I can system out print line it. I can say val equals plus val. All that's going to work. I'm going to comment out this line 13 and run it just to confirm for you that it's going to work. So there you see val is 15 and object A val equals 10. So this val that is local to class B and is inside of objects created from class B is entirely usable inside of this code where it's defined. It is an instance variable, so it's available throughout the class after line 24, but it's not visible or available outside the class. So in concept, this val is only for internal use by class B. Object A based on class A has a public field of the same name, and it's accessible. You can set it. You could also say object A.val equals 5. I'm just trying to keep the numbers. I miscapitalized that. Object A.val equals 5. That'll change our output to val equals 15. Object A val equals 5. So you might be wondering why the order is this way. Why is val equals 15 first? Because that's in object B, and we created object A first. So I know you might be looking at that and thinking, well, wait a minute, why isn't object A referenced first in the console? I don't know if you are or not, but in case you are, it's all flow of execution. The flow of execution in Java apps is these instance variables are read in and processed first. In this case, we've created two objects, so they are created. If they have constructors, the constructors are executed. A doesn't have a constructor, so there's no additional code that's run. But we put a constructor in B. So when this line of code here on line 5 is executed, then the constructor is executed. And that's why we see val equals 15 at the console first, is because that's the next statements that are executed. They're in the constructor when we create objects of that type B. The main method is executed next. The main method runs the constructor for the class if it's present, and in the class constructor we do the second print line. But it's hit after object B has been set up and its constructor is run. So that's why the order, it seems backwards to you, that's why it is what it is. All right. Let's say maybe we need to do a little bit more involved math here, which is val times, maybe val times 15, maybe val times 10. And let's just say that you realize that's going to be something that you're going to need to do a lot of, is that little bit of math. And it is multiplied by 10, but maybe there's the possibility that that 10 will vary based on something the user enters or something that's read in. So you don't really want to cut and paste that val times 10 everywhere you think you might need it. You want to turn it into a method. So let's highlight that, and I'm right-clicking and choosing Refactor and Extract Method. And I'll pause there for a little bit just so that you guys can see it. There is a keyboard shortcut. That's not one that I've committed to memory. I mean, I just don't refactor that many methods. Unlike reorganizing imports, which you do every few lines of code you type, it feels like sometimes. But you can always find it there under Refactor Extract Method. All right, I'm going to select that. And this gives me the Extract Method dialog box. So it's determined that it doesn't need any parameters, although my intention was for it to take a parameter. So I'm going to back up and copy the whole line, or select the whole line, maybe see if that makes a difference. What you select will drive what the refactor process tries to do. Now it still doesn't see it. I want to use the refactor and then we'll fix it and make it do what we want it to do, because I want to show what this works like. So this is multiplied by, that's what I'm going to call it. I'm going to hit OK. And you can see it's replaced the little bit of math I did with this method multiply by, and it's called multiply by. But the idea was I wanted to be able to customize the factor. So I'm going to add a parameter called factor. I'm going to replace 10 with, I'm going to try to replace 10 with the factor, and then I'm going to pass it 10 here. Okay, that's what I was hoping Refactor would let me do a little bit more easily. Not that this was terribly difficult, but this is going to do the same exact thing it would have done if I had run it before doing the extraction. So it's multiplying 20 in this case by 10, and then outputting the value, so we get at the console val equals 200. And then if I want to make changes to this formula, I only have one place I would need to go to make those changes, and it was super easy to create the method. I meant to say also that what it pulled out is slightly different than I actually was wanting. It does work, it is multiplying val by 10, but the line of code I really wanted something more like val equals multiply by 10. And so I don't really want it to do the assignment in here. I just wanted to return that math and then plug it in there. So to some extent you have to think, well, how do I want to use it? What's the syntax I want to use? And then you can write the method to meet that need. This should run, hoping exactly the same, yeah. Okay, so what about this? The public method, and what that means is it is accessible. So if I try to do something up here now with a system out print line, we're going to say, object A multiplied. So I want to access, not object A, sorry, object B. We're looking at object B. So I want to look at object B and hit dot. And so I don't have access to val, but I do have access to multiply by because it's public. And so I can run multiply by, pass it whatever factor I want, and get the result back and use it. So, all right, I'm a little confused by it's 400 though. Oh, it's because I already Yeah, I already multiplied it by 10, so that was 200, and then I doubled it to get to 400. But if I make it private here, what you'll see is it doesn't change anything in this class. Public and private don't describe access to code inside of a class. Public and private determine what you can do outside of class B, for instance. And now what you'll see up here is now I don't have access to multiply by anymore. Since I privatized it, it's now hidden and I can't use it. So you really do want to think through the access modifier. You can also leave the access modifier off, which is what we've been doing in our methods and our attributes. Actually, I don't normally declare things to be public. I just leave the public off. So if you leave an access modifier off, you get something called default or package level access, which means it's like public, except it's limited to the package all of these classes are in. So in this case, I'm in my Eclipse, I'm in Chapter 9 Methods in the default package. So that would mean that anything I put in this package could use these attributes, for example, or this method, for example. But other code in different packages could not. All right, let me switch back to the Keynote. So I'm still on UML because that was a bit of not a tangent, but that was something I wanted to cover before I got to UML. There is one other access modifier that I mention whenever I'm saying all of them, and it's protected. And protected is a kind of a hybrid modifier, and it will only make sense after we've covered Chapter 11 on inheritance. So I defer, additional discussion of protected until we get there. So Unified Modeling Language, you guys may have already learned in another class. Certainly it is the standard manner in which we visually design programs and visually communicate what a program does and how it does it. So the idea is that it's not based on any particular programming language, rather it's based on the concepts of the language. It does support object orientation, so it works well with object-oriented languages, and one of the basic things that we do in UML is we describe how the app is designed from a class layout point of view. That is, how many classes are used and how are they related. And typically we restrict it to the classes we ourselves write or make. So in other words, the UML doesn't necessarily need to say, well, we're using JFrame, and here's all the details of what's in JFrame. Because people don't need to know necessarily what the methods in JFrame are, and what attributes JFrame has, because it's standard in Java. What they need to know about is, okay, what's in your customer class? Well, what's in your, point of sale class? What's in your whatever custom class that you've made, which we'll cover in the next chapter? People will want to know, okay, what did you put inside of it? What attributes does it have? What methods does it have? And what is the nature of those attributes and those methods in terms of visibility and how I might go about using them. So that's where UML is handy. And again, it is equally well descriptive of Java apps or C++ apps or any other object-oriented app. You would use the same exact visual description. So the class diagram uses these boxes. And each box is broken into 3 parts. One is the name of the class at the top. Second is instance variables. So these are attributes or fields. And then there's a list of what UML refers to as operations. In Java, these are called methods. You could also call them functions or procedures. So it will look something like what I've got listed here, except with actual data placed in it. It will also communicate to you the access that you would have to elements that are inside of that class. So the UML will describe everything that's in the class, but that doesn't necessarily mean that you'll have access to all that stuff when you create objects of that class type. So you also need to know the access modifiers for everything. And instead of typing out public, private, protected package, UML uses symbols. The most default character-based symbols are the plus, the minus, the pound, and the tilde that you can see here. And lots of UML packages use, when you're trying to design and present these sorts of reports, they'll use a little bit fancier symbols, but they all will boil down to the plus, the minus, the pound, and the tilde for public, private, protected, and package. To make simple UML diagrams, I just use the basic symbols without trying to fancy them up too much. So for each attribute in the UML, you'll list the data type, you'll list the name, the identifier, and you'll list the accessibility or the access modifier for it. For each method, you'll do basically the same stuff, in that you'll list the accessibility again, the access modifier, the name or the identifier. You'll list any parameter types, data types, and if the method returns something, you'll list the return data type or the keyword void. The sticky note there says that a hidden attribute is a happy attribute, which is just one of our goals in designing our apps will be to hide stuff that people using our objects of our type don't need to see. So if something can be private, in general, we like to make it private so that we don't give easy access to parts of our code that other programmers shouldn't have access to. The other thing in the UML diagrams is relationships, so we'll use arrows to link together classes that fit together in a single app. So a solid line and a solid closed arrowhead will mean inheritance, which we'll get to in chapter 11. Dashed line means implements, like with listeners, and then regular arrows will point to superclass, subclass kind of relationships, or relationships where one class uses another class. So as just a simple example, I went through DoubloonMethods and looked at what would it look like in a UML diagram, and this is one way that you would do it. DoubloonMethods is a subclass of JFrame. It's a windowed app, so it extends JFrame, so the solid arrow points up to the superclass. It uses action listener, so it implements action listener, so the dotted line indicates any classes that it's making use of that are built in essentially to Java. And then everything in the huge box there, DoubloonMethods, is exactly what I just described, which is a list of the instance variables and then a list of all the methods. And if you were to line this up with the DoubloonMethods code and look back and forth, what you'd see is I've just done these in order. There's the serial version UID, which is private, and then there's the default JText area, scroll pane button, and the two data arrays that we talked about last time. As has been the custom since the start of class, I haven't declared them to be public or private. I didn't include an access modifier at all, so they are default or package level access, which is indicated with the tilde. And then looking down at the methods, you can see there's the main method. It is public. And then there's all of the other methods that I created, which are package level access. And at the end, there's action performed, which is public again. So main and action performed are on that list of that which must be public. So they are public. If you made them private, the app would not work. The only other thing to note is that in the list of the methods, you'll see the return type is listed afterwards. So for instance, drawLine is a void method. It doesn't return anything. Whereas the end of line method returns the end of line character. getAverageBalance, for instance, returns a double. And then any parameter data is listed inside of the parentheses. So for instance, the second drawLine takes an integer parameter, which is the style parameter. So a quick glance at a UML that's laid out, decently readably, gives you a really nice big picture idea of what that class is about, what kind of features are in it, and what kind of features can I access and see and use. The other thing I did in DoubloonMethods was come back to this 4-cell table that we started the chapter out with, where we have these different cells, 1, 2, 3, 4, that are determined by whether or not the method accepts parameters and whether or not it returns a result. And I just listed all of the methods that are in DoubloonMethods here in the table in the correct corresponding cell, so that again, if you're looking at DoubloonMethods as an example to look back to look for some kind of a method or help writing a method, you can always come back to this table. But again, in DoubloonMethods, I also have the 1, 2, 3, 4 cell as a comment, and all of the methods are flagged as being of type 1, 2, 3, or 4. All right, so the thing a lot of people get stuck on is just these two questions. We have this 2x2 cell, we have these two questions we need to ask ourselves and to answer, and the answers will drive how we write the method. So these are the two key decisions: is do I take parameters or not, and do I return a value or not? And you have to know the answers to some extent to write the method, although you can get these answers wrong and still get the program to work It just might make the syntax a little bit more involved, or it might introduce other issues that are undesirable, but that don't necessarily keep your program from running. There's two simple rules that will maybe be helpful when asking the two questions. First off, passing parameters. The tip here, the rule here is there's never any need to pass an in-scope instance variable as a parameter. These are already available throughout the class. If you've defined something to be an instance variable, it is already available to any method you write in that class. That's the whole thing about instance variables. That's their thing. There's no need to pass an instance variable to the method to do something to the instance variable because the instance variable is already accessible in your method. You can just refer to it. And then in terms of returning a value, if the purpose of the method is to change the value of an in-scope instance variable or object, there's probably no need to return the result, because changes you make to an in-scope instance variable in your method are actually changing the value of that in-scope instance variable. You don't generally need to then also return the value of the variable to the calling line of code. On that calling line of code, you can just access that in-scope instance variable because it's in scope. So the rules are actually kind of similar. If your method's working with in-scope instance variables, you probably do not need to pass those as parameters, and you probably do not need to return those as results. If you're looking at your code that you want to turn into a method and it has variables in it that are local, that are not instance variables, then it might make sense that you'll need to pass those because you won't necessarily have easy access to them inside of the method. Otherwise, you need to sort of hand off that data to the method and let it work with it, and then maybe also let it send the result back after it's done working with those local variables. So the rules, to a large extent, will be driven by the data that you want to use, and if there's a result you need after the method is run. I've got kind of a corny flow of execution paragraph here. I'll let you read through, but I had this idea that getting your head around flow of execution is crucial. I know you guys are getting better and better at it, but it's still sometimes you see some of these examples like the one we had today where it wasn't necessarily super clear why object B results were being listed before object A when we created object A first and object B second. Understanding flow of execution revealed why that order was the order. Anyway, I had this, again, kind of corny idea that, flow of execution made me think of a diner, server named Flow. And if you're playing Diner Dash with Flow, sort of when Flow moves around, it's like the flow of execution. So Flow, takes instructions from the tables and from the kitchens, and then Flow goes to tables to figure out what they want to order. You could think of tables and stations as methods the flow of execution is going to. Flow takes things to tables. So, for instance, it takes menus to the table. The menu could be thought of as the parameter. And Flow takes from the table their food order. And that could be thought of as the return. Anyway, if you think about it too much, I don't know how well it holds up. But if you like analogies, corny analogies, you can read through it and think through it. And if you have ways to improve the analogy, please feel free to let me know. It's just meant as one additional way, maybe to help you master, or at least take a big step forward with flow of execution. So that it isn't a puzzle to you, but it just makes really good sense. This was a big chapter, easily a 2-day chapter. Obviously, methods are a big topic. You've already been doing a lot with methods, and I've used methods over and over again in prior examples, so that I'm hoping this chapter doesn't rock anybody's world in terms of, oh my gosh, I did not realize you could do that, or anything like that. I hope this was all fairly familiar. Access modifiers are new because I've intentionally left them for today, because they really won't kick into gear until chapter 10 next time. And then you also learn the basics of UML if you haven't already learned UML. Now you can read basic UML charts and make basic UML charts. That is all I have for today. That's the end of chapter 9, methods. We approached it carefully, or should I say methodically. I hope you're not afraid of methods or the syntax or intimidated by them, because they really are a crucial key to making programming much easier and making your programs better.